Hi everyone, I'm Vincent Surtsvitz, and I'll be presenting our project on the design of bionic flapping and folding wing mechanisms. So our objective was to research, design, fabricate, and test flapping wing mechanisms for lift and thrust, and to use either folding or twisting motion to improve that performance. We also wanted to optimize the initial design and compare our results. So, recent research shows increases in aerodynamic performance, energy efficiency, and flight maneuverability with the flapping wing mechanisms as compared to traditional fixed wing and rotor wing flight systems. The use of folding or twisting is also shown to reduce the negative lift on the upstroke and improve the flight efficiency. And this project was a remodel of last year's project to improve their performance. The applications for this project would be for micro air vehicles, and that would be for wildlife management, surveillance, military, and delivery services. And right now, the MAV field is dominated by rotor wing drones, but with more research, we can see more flapping wing mechanisms. So, to go into our design alternatives, we considered a few different kinematic mechanisms, including the Scotch yoke, the single crank slider, and the double crank. We also looked into either folding or twisting to incorporate into our design. And our final design was a double crank with single axis folding. And we decided on that due to its symmetric flapping, the folding without a multi-axis, its simple and compact design. And you can see our CAD model and a demonstration of the kinematic mechanism. Now, for the kinematic layout, the mechanism could be broken into two separate four-bar linkages. So we made two loops here. And based on these loops, we were able to solve the position and velocity at different input crank angles to verify our mechanism here. And for the wing design, we went with a wing aspect ratio of 7. And this was based on some research with different birds. And we went with a Dacron material covering as well. And our shape was bird inspired with an angle of attack of 15 degrees. And from there, we were able to determine what wing shape we would use. So then we went on to model our design after coming up with everything. And we use Autodesk Inventor CAD software to do so. And we use different assembly constraints so that we could simulate the flapping motion in that 3D model program there, which is great. And the fabrication. So we ordered a bunch of parts such as the motor, gears, O-drive, and then 3D printed a lot of the links, the wing frame, the base, and installed the load cells. And after we had that, we went into optimization for the design. So we looked into a linkage program to potentially optimize our links. So as you can see, the link on the end there was changed into a triangle wing. Try to move my head so you can see it. Yep. And that actually ended up helping us a lot with the folding motion there. So we did a simulation to compare optimized and unoptimized design results, which showed nearly zero negative thrust and lift, which is great, and more than double the average lift and thrust, which is awesome. So here's a video of our optimized design fabricated. And our testing, so we clamped down the model for over an overhang and had the wind tunnel in front of it. We utilized load cells to measure the thrust and the lift and ran the flapping mech at 1 to 6 hertz flapping frequencies. So for the lift, we were able to have an increase overall in the performance by 384% compared to last year's design. And this was mostly due to utilizing that folding motion there. And the thrust, we did see a decrease, unfortunately, in the thrust, but this was likely due to our angle of attack and not a major cause of concern there, only 11%. So in conclusion, this project proposed our design, simulation, and we did some experiments to analyze our flapping wing mechanism and improve its aerodynamic performance from last year's design. We were able to show that the folding motion decreased the negative lift produced and made it more aerodynamically efficient. And yeah, that is our project. We would like to thank you for listening to the presentation and considering us. And here are our references.